Hi, this is Michael McConnell, editor of Snips, and I'm here at SMACNA 2011 with Kip Ivey, and we're here to talk about one of Trimble's new products, how they can take their office work into the field involving BIM. Is that right, Kip?
Correct, Mike. What we're going to look at today, obviously in this BIM world that we live in, everything in our sheet metal industry today, many of our contractors are starting to draw in 3D. So we want to be able to do more with that information than just create a pretty picture. So what we've got on the screen today right here is a product called Trimble Design Link. It works inside the MEP environment. You can look right inside. We have some ductwork real simply. So what I'm going to do is I'm going to draw some ductwork real quick. We'll throw some square ductwork, some round ductwork, and then what we're going to do is we're going to create some points. Those points are an XYZ position, for example, of a hanger. And we'll take that hanger information, we'll move it over into the Trimble Total Station and show you how we can take the information from this model to the field to increase productivity.
Great.
All right.
Okay.
So on the screen you see we're drawing inside the 2012 MEP environment with Trimble Design Link. You notice all I'm really going to do is I'm just going to real simply just going to come on here. I'm going to click on a piece of ductwork. I'm going to go ahead and extend that ductwork out. We've got a little routing preference here. We'll move this over. So I've got some ductwork. We're coming down. So I'm going to come down in this direction. Now maybe I want to change my shape from rectangular. So we'll just simply say, look, let's grab some round ductwork now. You'll notice that it automatically throws in my squared around, and I can continue on down the run real simply and then just turn in that opposite direction. And there we can end that run.
Looks really easy.
Well, it is relatively intuitive. For anybody that is familiar with the MEP environment, learning curve with the Trimble Design Link is be rather simple. So it's not going to require an exorbitant amount of training, I think, to get somebody up and going. So once I've created that information, I want to be able to take this. I want to be able to create intelligent information. So simply I'm going to tell it to break the information up. You'll see that now no longer do I have a single piece of ductwork. I have multiple joints with actual true connectivity with a flange-to-flange connection. So now that we have our ductwork drawn, now we want to increase the productivity in the field. So the first thing we need to do is we need to create some points. Like I said, that point could be as simple as a hanger position. So over here, I have a little thing that says Insert Routing Points. So if I click on that, it says, what do you want to do? What kind of points do you want to create? So obviously we're going to hang in ductwork, so we need double points, one on either side of that piece of ductwork. So I'm going to simply say I want to create some double points. I can tell it down here, I can tell it, for example, I want to place those points at a defined distance, right? Obviously, SMACNA has the ability to say, I need you to hang your ductwork at a defined interval. So I'm just going to say, look, I want to place those points every 60 inches, all right? So I simply tell it that information. I say, okay. I just come up here and I tell it, I want to start my routing, and maybe I want to route in what particular direction do you want to route here? So I'll grab my routing points. Let's say, okay, I'm sorry about that. And I'll just grab this point, say we're going to click that point. You can see that we now have actually placed the hanger positions in relationship to the square ductwork. Now we're going to round. So if I was going into a round situation, it may require me to go from a double point situation to potentially maybe just single if I'm hanging with strap or wire. At that point, I just got to just simply come back and say, look, I don't want to do double points. Let's do single point information. And I say, okay. We'll zoom out of our drawing here just so you can see a little bit more in detail. And you can see that we have now our single point information for the hanging of the round ductwork. Okay? So now we have the XYZ position of the hanger. We have our 3D model created. We have our intelligent ductwork created. So now I'm going to come up here and I'm going to simply say export to Trimble Field Link. You click on Trimble Field Link. Say, what do you want to do? Let's go ahead and export this entire drawing. And I say okay. The file is now created. Now I can take those two files. One is the point file that is created from the model space itself, and the other is the wireframe or modeled background, so my guys in the field have more information rather than just a bunch of dots.
So Kip, what's the next step in the process?
Well, we've created the two files originally from our model space. We brought a point file and then that background image, which you'll see on the screen here in just a minute, of the model itself. And then what we've done is we need to take that information and move it forward into the Trimble tablet, which is the new controller for the Trimble robotic total station. So right in front of me, you'll see we have the Trimble tablet. We'll go over some model information, and we'll show you how we lay out some points.
Great, let's go over it.
So what we have on the screen is the Trimble tablet screen. You'll notice that one thing unique about this particular controller is we are actually running the Windows 7 environment rather than Windows Mobile 6 environment. So this isn't just a controller, it's an actual tablet PC with a 7-inch touchscreen. So there's many other ancillary things I could do with this tablet besides just use it to control the robot. But obviously today we're here to talk about the Trimble FieldLink software. So I'm simply going to open up the FieldLink software. Now you'll notice on the screen what we see is an actual 3D model of what we originally created. I can go ahead and I can look at this model, I can kind of pan around and move. Now the reason we give the guys this information in the field is real simple. We want to give our guys more information, because the more information we give them, then the better understanding they're going to have about exactly what we're trying to produce and what we're trying to do. So I actually have a model here that I can rotate, and I can look at it in multiple views. Simply by touching the box on the bottom, I can rotate around it into a simple Southwest isometric view, so my guys can physically see that that ductwork is coming up and over and around and down the hallway. Okay? So as far as laying out points go, you'll notice if I hit the Trimble bubble, it brings us to what we call a ribbon control. It allows the user to create a more task-oriented layout. So I can simply say, look, what do I want to do here? I want to lay out some points. And it opens up a screen. You'll see, once again, you'll see that wireframe background of that we created, and then we have the dots. Those dots are our points, the points that we created originally from our hangar space. But you'll notice that over to the right, I have a point list, but I don't have any points created yet because they're in the drawing, but I, as the end user, I need to determine what do I want to do first? What do I want to do second? I want to be able to create a workflow rather than just arbitrarily just start laying out points. So I can, if you look on the screen, you'll notice there's a little hash mark. It looks like an orange box. That is me working within the model space. So as I move around, I, as the operator, can physically see where I am in relationship to my model, in relationship to the instrument. So now I say, look, I've got a bunch of points right where I'm standing. So I want to grab those first. So real simply, and it's going to open up this box. I'm going to drag a box around that particular area, and then it populates my point list, because these are the points I want to lay out first. And then simply I just go over to layout, and now I can make determination, what do I want to lay out first? So I want to lay out a hangar. I'm just going to touch that hangar here in my drawing, and then it goes and automatically goes into what we call puck view or bullseye view, depending on your point of reference. So you look on this, what you'll see on the screen, it kind of looks like a TomTom GPS. It gives me the ability to walk backwards, and it's guiding me, telling me exactly what direction I need to walk and how far do I need to walk. So it's telling me I need to walk roughly 2 feet backwards and 9 5/8 inches over to the left. So as I get close, I continue on back to that particular point, and really at that point, once I'm over top of that point and inside my assigned tolerance here, a little bit farther back, I get this. It's a visual, very visual for the end user. All those arrows go neon green, so it tells them, hey, you are there. This is where that hangar is located. We can go ahead and stake that point. It takes a final measurement to make sure that I'm in the right location. It tells me that I'm inside my assigned tolerance. I've laid out that point number 61, which was a hangar point, and I can say, let's go ahead and store to the nearest point to where I'm standing, so I'm not running all over the building, and I can move forward and do it again.
Well, thank you, Kip.
Well, thank you, Mike. Glad we were able to take the time to visit us here at the Trimble booth, so how we can take this information from the office to the field and increase productivity for the members throughout SMACNA.
Appreciate it. And this is Michael McConnell with Kip Ivey here at the 2011 SMACNA Convention. Thank you.